In this video, we're going to talk about how we convert between radical and rational exponents. So a rational exponent is just a fractional exponent. And so we talk about rational exponents, we're talking about a fractional exponent. And it can be written in radical form. So when we talk about a fraction, our bottom is always going to be on the outside of our radical, and the top is always going to be on the inside. So I'm going to have 2 root x1. Well, the square root of x is just the principal. So if I have the 2 root, it's really just the same thing as the square root, and then x the first would just be x. Similar with this one, so your bottom number is always your root index, the top number is always what's in with your x. So cubed root of x squared. Again, 2 on the bottom means it's the square root of x to the 5th, but we don't write the 2, we just write it as the principal root, x to the 5th. All right, so if we're going to rewrite these and simplify, if I have the 1/2 power, that's the same as the square root of 36, which would be 6. This would be the same as the cubed root of 8 to the 1st, which is just the same as the cubed root of 8, which is 2. This I'd write as the cubed root of x to the 4th power. And then this one we write as the square root of x to the 7th power. Now if we wanted to simplify this, x to the 4th power is x times x times x times x. So if I have 3 x's, that means 1 x comes out and this x stays in. Same idea here. I have 1, 2, 3, 4, 5, 6, 7 x's, and my index is 2. So I'm looking for pairs. So I have 1, 2, 3 pairs. So 3 x's comes out, and the 1 x that wasn't part of the pair stays in. All right, now if we wanted to rewrite it the other way. So if I have the square root of a, that means this is the second index. The square root of a is the same as a to the 1/2. The 4th root of a is the same as a to the 1/4. This 5th root of a3 is going to be a to the 3/5 because the power stays on top, the root goes on the bottom. Same with this one, x to the 4/5, 5 stays on, or sorry, 5/4, 5 stays on top, 4 goes on the bottom. Square root is an index of 2, so it'd be 3/2. This would be x to the 1/3. This would be x to the 4/6, which can be reduced to the 2/3. So part of being really good at roots is knowing our perfect square roots and our perfect cube roots and our perfect 4th and 5th. So there's a little table that kind of outlines all of our perfect squares, all of our perfect cubes, all of our perfect 4th powers and 5th powers. So kind of keep these in mind. So we're going to use these to evaluate. So I have x to the negative 1/2 power. So keep in mind anything to the negative has to go to the denominator and become positive. Now a 1/2 power is the same as the square root of 25, and the square root of 25 would be 5. So this would simplify to 1/5. Now our bottom number is the index on our root. And so I'd have the cubed root of 8 squared. Now you could also write this as the cubed root of 8 squared. And I know that the cubed root of 8 is 2, so 2 squared would give me 4. You could have also said, oh, it's the cubed root of 64, and the cubed root of 64 is 4. So either way, you could have gotten to that answer. Now, 125 to the 1/3 power is the cube root of 125, which if I'm looking for cube roots of 125, it would be 5. All right, so if I do this on the calculator, I would rewrite this as the square root of 32, and when I type that in my calculator, I would get 5.657. I would rewrite this as the cubed root of 24 squared, which would get me about 8.320. This one I get 1 over, well the 2's on the bottom, so it's the square root of 82 cubed. This would be 1 over just going to type that all in my calculator, so 0.001.